Hello everyone, this is Professor Keen. In our last lecture, we began to talk about William Gilbert's book On Magnetism, or On the Magnet, which was written in 1600. I think you'll find that some of the language that he uses, you're probably unaccustomed to it, some of the terminology he's using. So I think it's really useful to look at the historical context to help us grasp the kinds of issues that Gilbert was dealing with at this time. And one of the first things that he talks about in his book on magnetism is how if you pick up a rock, some particular rocks called lodestones are found to orient themselves. So if you were to place them on a small wooden float, for example, and put them in a still pool of water, the lodestone would rotate until it orients itself in a certain direction. And if you were to take two of these lodestones, then they would sometimes orient themselves with respect to each other, or they might attract or repel one another. These we know are called magnets. That terminology is actually quite ancient. They were called magnets because they were from a region called Magnesia, which is a region in what is now Turkey in Asia Minor. Anyhow, the question is, why do these rocks, unlike regular rocks that you pick up off the ground, why do these particular lodestones or magnets orient themselves? Now you might say, well, that's obvious because they're magnets, there's magnetic fields, but keep in mind that you have never seen a magnetic field. So simply stating, well, it's the magnetic field, doesn't really give the kind of explanation that we're hoping for. And in any case, it's a very, very strange thing. In fact, it's one of those things, the more you think about it, the more peculiar it seems. After all, why is it that a rock here can pull or push on a rock here without anything touching them? You can put your hand between them and they attract or repel one another. This is a very mysterious thing. It's almost magical seeming. And so what William Gilbert is doing, he's saying, let's try to get a better grasp or understanding of what's going on with these magnets. Now, one of the things he does is talk about some of the previous theories of magnetism. What is it that causes magnets to orient themselves when you place them on a wooden boat or when you suspend them from a string? And some of the ideas that he discussed were that the source of motion for a magnet, or the thing that is trying to orient it, that power lies outside of the Earth. In fact, in the heavens or in the stars. That was a very common view. After all, these magnets kind of orient themselves toward the north. And so what is in the north? Well, Polaris, the North Star. So perhaps it's the stars that are exerting this pull on them. And you'll see there's also this sort of tendency to attribute things that happen here on Earth to things that happen in the heavens. There's an astrological component to this thinking. Gilbert, on the other hand, says, no, it's not the stars that are exerting an influence on these lodestones. It is the Earth itself. He has a mundane or earthly approach to this. But, for that matter, he says that the Earth itself is oriented with respect to the stars. After all, the Earth is spinning around an axis, and this is oriented toward Polaris or the North Star. In any case, although the Earth orients itself with respect to the stars, he says that lodestones or magnets are oriented with respect to the Earth. Okay? And so what Gilbert then does is he begins describing a set of experiments that he carries out with what is called a torella. And you might think of a torella as a spherical chunk of lodestone, this magnetic material, that he can then use as a model of the Earth and see when you hold other magnetized objects near it, the way that they orient themselves. So I'm going to cut my webcam and talk about some of the experiments that he carries out, and then we'll take a slight detour into how he's going to interpret. Okay, so what is a torella? Let's ask this question. So here's our first question. What is a torella? And what does it teach us about magnetism? Okay, so what is a terrella? Like I said, it is a spherical lodestone, one of these magnetic rocks that you may perhaps chisel or polish into a round shape. And he's going to identify a couple of points on this. He calls it point A and point B. Of course, these aren't colored. When you dig this up, it's not colored or labeled with an A or a B. But nonetheless, these are imaginary points on it, and he's going to draw an imaginary line like this on it. And he says that if you take a piece of magnetized iron wire, so imagine a piece of magnetized iron wire, and you were to suspend it from a string. Okay, so here's a string, and this right here is a magnetized iron wire. He'll talk more in a little while about how you magnetize iron wire, but if you'll just grant that you can take a piece of iron wire and magnetize it, hang it from a string near this torella, then what will happen is this wire will orient itself. It will orient itself compared to this torella. If you were to hang it here, it would orient itself in this direction, and if you hang it in different locations, it will always be orienting itself compared to this torella. Okay? And he says this is very similar to the way if you were to think about the Earth as a whole. So the Earth is a sphere like this, and there's a north pole of the Earth and a south pole of the Earth. I know I'm putting it on its side, but that's okay. We can imagine looking at Earth from the side, and we've got an equator right here. If you were to take a compass needle and you were to hang it from your hand near the surface of the Earth, this compass needle will orient itself compared to the Earth. So the compass needle is to the Earth like one of these magnetized iron wires is to a small torella. And this highlights one of the central points that William Gilbert is making here. He says that magnetic bodies, like this magnetized iron wire, magnetized bodies, they conform to the globe of the Earth according to the same laws or patterns, you might say, the same laws or patterns, and in the same ways that a lodestone or any magnetic body conforms to a torella. By the way, torella, you might see terra in here. That's the term for the Earth. So this acts like a little Earth. Okay, and this is this is an exact quote, but a near quote from page 5 in A Student's Guide Through the Great Texts, Volume 3, Chapter 1. So that's one of the main points that he's making. You can use this torella as a model of what's happening with the Earth. Okay, so notice that the Earth, he's arguing that this compass needle isn't pointing toward the North Star over here. It's conforming itself to the Earth in the way that this is conforming itself to the torella. One of the things that Gilbert also says, he says that he calls it a verticity. This is how he summarizes it. There is a directive force which he calls verticity. Verticity distributed by the Earth which orients compass needles. Okay, so the Earth has this directive force that somehow emanates from the Earth, which is able to orient the compass needle. And likewise, he says, a torella, that is a magnetized lodestone or other body, a magnetized body like a lodestone, also distributes this directive force. Directive force, okay, which orients compass needles. Okay, so there's sort of an equivalency going on here. Okay, and then he goes on to say that the terrella, maybe I'll go up here, the terrella has the same form. I'm going to underline this for reasons that will become apparent in a moment. The terrella has the same form as the Earth. Okay, this is on, I think, about page 5 or page 6. Page 5 or 6 in the text. Now this term, the same form as the Earth, what he's saying here, this is a loaded term. He's not saying it has the same shape as the Earth. It has like a circular shape just like the Earth has, because after all, you could have cut this lodestone into a cube. So he's not talking about form in the same way that you might have assumed he's talking about form. He is referring, this is loaded language. This is very important language that he has inherited from the Aristotelian tradition. Aristotelian and medieval tradition. Aristotle, you might remember, was the ancient Greek philosopher, about 200 or 300 BC, and his ideas were very influential up through the ancient times and the Middle Ages, up to the time of William Gilbert. And what he's talking about here is that they have the same, the torella and the Earth have the same formal cause. When he says they have the same form, he means the same formal cause. Now, this might not elucidate things or clarify things for you at all to say, what does he mean by form? He means formal cause. And so what I think we should do is we should review, for the moment, the Aristotle's four causes. Because the formal cause is one of the four causes that he's talking about here, and will give us a better understanding of where William Gilbert is coming from. And what we're going to do in the next lecture is we're going to review Aristotle's four causes, and that will give us a sense of how he's thinking about this. So let's stop there, and we'll come back to this briefly.